So here's a quick agenda of what we're going to talk about today. So basically, Zoox started with a kind of realization that the model of individually owned human-driven vehicles is broken. And there is a lot of evidence that supports that, like starting from the asset utilization, kind of congestion, and that in general, it's not really safe for people. Basically, a lot of people die on the roads every year, and it's bad for the ecology. So our founders realized that the transformation is necessary. So similar to how we went from the horse carriages to the automobiles, we need to go from the current model of automobile to something like next. And the mission is to create autonomous mobility from the ground up. So Zoox as a company has both software component and hardware component. So basically, like Zoox is developing the software for the vehicle to drive itself, as well as actually developing the vehicle that is purposely built for autonomy. And we, as a data science team at Zoox, have our own mission, which is basically provide insights using data that informs strategic decision making. And there are like three core functions that we perform at Zoox, which is enabling data analytics, which is basically building tools, data sets, kind of providing the access like to data for all our stakeholders. We also do analysis projects ourselves. So like when we have like a big set of data like coming from the vehicle and we want to understand like what's happening in certain situations, like we would do that ourselves for our stakeholders. And like lastly, like we also perform kind of data advisory function when like some of our stakeholders want to make an analysis on their own data that we currently don't really manage, but they kind of want to make sure that their analysis will produce results that are like statistically sound and the methodology is valid. So we will help them out. And you can see the DBT is playing like an important role in our stack because that's how we manage all our in-warehouse transformations. And ultimately, we kind of surface those models that we build using DBT by reporting layer in Looker. So that's kind of the brief setup of like both Zoox and the how we use DBT. And then why like data reliability? So I think like the best way to illustrate that is like to show like these like real quotes from like emails that our CTO sent us before we set out on the project of improving data reliability. And you can see that data reliability issues like really hurt users' trust. So like when users see something in the data that they don't really expect, they start questioning whether the data is actually accurate or like it's what really happening. So feel free sharing your like war stories in the chat in Zoom. Like I'm pretty sure that everyone who works with data has something similar going on. But the main idea is that the trust is the key asset that data team can have, because you have to have trust for management to trust your recommendations and accept your recommendations. And once you lose your stakeholders' trust, it's really hard to gain it back. And until you gain it back, all your recommendations will be put under like a giant question mark, like whether or not like this like recommendation is based on some sound evidence. And kind of when you kind of think about where kind of data reliability issues can come from, you can say that there are like both like internal and external problems that you can have. And the internal ones are the ones that basically you kind of self-impose on yourself. Like you kind of timing of data updates, unchecked assumption about data sources, logical errors, meaning like you didn't properly use like SQL, like basically you didn't kind of encode the logic that you wanted to encode. But there are also external problems because as data teams, you usually consume data that is produced by someone else. And like upstream teams can create all sorts of troubles for you and for your models. But the main idea for data reliability is that no matter whose fault it is, like it's your responsibility to address them and to fix them and to bring the data back to its kind of healthy state. And that's kind of a good segue for like a Zoox framework for DBT tests. And like you may wonder like why, I don't know, like, okay. So when we started on this process, like we basically decided to set like the first principles of what data reliability is and how we should approach data reliability. And we kind of create like three main kind of points. The first principle is that it's better to have stale data or missing data than data that is actually inaccurate. So it's better to be like late with the data update than to update it like on time but have like faulty records in the end. The second one is better to be proactive instead of reactive, meaning that you shouldn't wait for your users to tell you that there is a data issue. You should be the first one to know that there is a data issue. And if you can't fix it on time, you communicate with your stakeholders saying like, hey, like we're dealing with this issue, like basically the data is stale for the time being. And the third one, and like not the kind of last but not least, traceability and observability. When you have the data issue, you should have basically enough breadcrumbs to be able to recover what exactly has happened and why you experience issues that you experience. So why kind of testing? So like we talked about data reliability, but how is it related to testing? And in general, like testing is a practice that in software engineering is like considered to be must-have. Like you have to have unit tests, you have to have integration tests, and there are a lot of tooling like for kind of this purpose. Like even for Python, you can count like libraries and libraries of how you can perform your unit tests. While for data analytics and engineering, like running tests on big sets of data is kind of tricky. So like how do you encode all your test cases that you really want to check for? And until recently, there was like no tooling for writing like data tests. And actually like testing is the best practice from software engineering. The DBT allows you to bring into your data stack. And that's like a really important point here. And then there are like conceptually two main types of tests. Yeah, so there is like runtime tests and continuous integration tests. And the first one, I can, thanks for Timo, like there is like a quick poll, like what tests do you run every time you perform DBT run? And okay, you can choose the one that you use like more often. And we will focus like this talk about the runtime tests. Basically, the tests that you don't test the new logic that is brought into the kind of into your project, but something that you run every time you want to update your model. You need to like run tests before you start. And the reason being is like to illustrate why it's important to run tests at each runtime of your DAG. You can look at this like very simple DAG, and like you have your. Well, it's actually really nice to see that 40% of people use schema tests, but only 23% use schema tests on sources. And here I'll show you why it's important to also run them on sources. So you have this very simple DAG. And in most cases, like you have sources on the left. And in most cases, you don't really have control over the data that lands into those sources. Because like sources is something that like by definition is something that you don't manage. So let's say like we start off with a DAG. It's in a healthy, happy state. And basically, as soon as like one of the sources becomes corrupt, your entire DAG becomes corrupt. And then someone comes up and says like, well, this dashboard looks weird. So you don't want to be in that situation. And schema test is something that allows you to kind of encode your assumption about sources in a very concise and like convenient way. So run them before you push data from the source into your model. And there is a trick that basically using this notation, you can run not the entire test suite on the source, but you can run particular tests specified in your source that are relevant for your model. So how does schema test work in action? So one of the sources becomes corrupt. You run the test, like you say, like, wait, don't ingest that. You trigger the alert, and everything else becomes stale, but it's at least not inaccurate. And as like I said, like our first principle that like it can be stale, but it should not be inaccurate. Yeah, are there any questions like for like up until this point? Because like this is like kind of explaining the schema tests, and now we'll move to more kind of exotic, I would say, way of like testing using like snapshots. Okay, like I think we can like have questions in the end, but so snapshot tests. So basically the idea is that like you want to know when your history changes. And like you can say, wait, like why can history change? And there can be basically few reasons. Some of the data sources are mutable by their nature. So like when something lands into the like original database, someone like a week later can reclassify a certain like object in that database, and basically your past history will change. And you can avoid that using incremental models, but incremental models have certain overhead, both like logical and compute overhead, to maintain them. So sometimes it's faster to run full refresh than build incremental models. So, but meta learning is that every time you run full refresh in your models, the historic data can change. And why use snapshots? So snapshots is like the feature that dbt provides, and it's convenient framework for change detection, and no need to write that logic of like detecting the change. And it has very clear and well-documented behavior, and it enables observability and debugging. So that's kind of why we use snapshot tests. And this is like very like, and there is a, I published the discourse page, like thanks Claire for like helping me with that. And that explains like all the technical details, and you have like a sample project that you can play with that implements this logic. But let's just go like through this example real quick. So when you run the snapshot, dbt will produce something like this. Like you have the table that basically valid from and valid to, and you check that basically for this combination of the keys, the metric value hasn't changed. And it manages these like last two columns as well as insertion of new rows. So the basic case scenario, like you kind of snapshot your model after you perform the the dbt run. You check all the values are the same, like nothing to do. But what if history changes? You detect that the history has changed, and then you kind of create the new record. dbt creates a new record for you in the snapshot table and invalidates the old one. So you can see that there is this record with dbt valid 2 that is not null. And that is what we're going to test for, like that our historic data hasn't changed. So you can test that using either data test option or snapshot as schema, like schema test on snapshot way. So like it's one of the two. But ultimately, basically, you fail the test if there is any record that is not null in that snapshot table. But the last step, like if you leave it like that, as soon as you have like one invalidated record, it will be sending alert every time you run dbt run, which is not ideal. And that's why I need to make it self-healing. And like you can read more about self-healing process in the discourse post. But the idea is that like you copy this record into your log table and you delete it from the snapshot table. So in the end, you have the log table that contains all the invalidated records and their past values, and your snapshot table is always clean. Like it's always valid when you perform the dbt run. So like to put it all together, basically on every job run, you put all invalidated records into your log table, delete them from the snapshot, run your DAG, snapshot historic values. And if there is anything that got invalidated in the snapshot, then you fail the test and you trigger the alert. So this is basically what your job, like if you implement both schema tests and the snapshot tests in your dbt run, this is what it will look like. You will have only one row that is actual execution of the model, but then you have schema tests and you have snapshot tests. But that's basically what you have to do to make sure that like all the data is accurate and valid. And like if something fails, you'll get, like if you use dbt cloud, you will get the email that tells you that this test has failed, and you can basically perform your investigation. So to wrap up, like so what? And I think like one of the most important learnings in this process for us was that it's not about alerts, it's about exposing weaknesses in your system. So when we developed this framework, we were getting a bunch of alerts at first. But when we detected like data sources that causing us the troubles the most often, we were able to engage with stakeholders and fix them. We also were able to detect issues in our execution of DAGs and the timing. So we addressed those. So as a result, we were able to improve quality of our system without kind of exposing and also preventing users to be exposed to the issues that we had. So we kind of increased users' trust, and at the same time, we decreased the time that we spent on troubleshooting. So lastly, like shameless plug, that we are hiring data scientists and data engineers. Feel free hitting me up directly, either in dbt Slack community or like via email. Note that like my last name is spelled with TS and not ST, so it's like timestamp name column. Because like most people like struggle remembering that, and it's totally fine. and there are open positions at Zoox careers. Don't be discouraged if you don't see data science or data engineer roles there, because like sometimes it just like there is a delay between like the job posting like being available and happening on the website. So that's it, and we have some time for Q&A.
Excellent. Thank you so much. So yeah, if you have a question for Evgeny about testing, like advanced testing approaches in general, feel free to drop them in the chat. I'll kick us off. This is a pretty sophisticated system. It's like, it's really cool. You know, as soon as a dashboard changes in a way that it's not supposed to, you're going to get a proactive alert about it. If you have any advice to companies about when might be the right moment to consider building something like this, because there's probably a fair bit of work to get it set up. Is it like the first thing you did, or was it when you just sort of got to this breaking point of like, I can't handle these dashboards changing anymore?
Yeah, so it's definitely not the first thing that we did. So basically, like we were how to say, yeah, like as many data teams, like you kind of deliver like results fast, and like you usually have like more requests than you have people to deal with them. So you have to like prioritize rigorously. And I would say that the right time to start setting this up is when you have data products that other teams are using and rely on. So basically, you want to make sure that like if someone else, so like when you have something that you use just internally, it's okay like if you have to like perform some manual checks before you deliver the analysis. But if this data product is used by the outside stakeholders, like you have to perform like tests and make sure that it's valid, because like as soon as it gets out of the door of your like internal data team, it's better be tested and valid, because like otherwise you jeopardize the trust like into your results.
Yeah, cool. So do you do this for all of your models, or just for like the main ones that are consumed by?
We do it for main ones. So like we have a lot of models that like are not tested right now. So like I'm just being like honest. But yeah, like for the models that like we kind of use for decisions or like used by like outside stakeholders, then yeah, like we make sure that they're like valid. So
Nice.
like basically you have like different tiers of the models, because like some models are there mostly like for debugging of some like technical like details of like what's happening like with the vehicle, and it's like a second tier. But the first tier is like the key performance metrics for like how a vehicle is actually performing when it's like outside on the streets.
Cool. I think just from my perspective of being able to see some runtime stats of DBT, if you're already using any kind of test, you're already in like the top 60% of DBT projects. Only 60% of projects use tests. And I think it sounds like Evgeny's team is sort of up in like, I don't know, the top very 5% in terms of testing frameworks. So really cool to see sort of using some tools that are already in DBT and figuring out like nice ways to put them together so that you can sort of take that framework and push it a little bit further.
Thank you.